Welcome to Look Learn Lead. Kindly subscribe and press the bell button for updates. Hello everyone, in this video we will be discussing about previous exam question paper which was held on 17 December 2017. In this video we will be covering first 10 questions. So before proceeding, please subscribe to our channel. Let's move on to the first question. And the first question is, suppose A is a finite set with n elements, the number of elements and rank of the largest equivalence relation on A are. Okay, we are talking about equivalence relation here. So what is the equivalence relation? So equivalence relation is a relation which is symmetric, okay, reflexive and transitive. Okay, this is the equivalence relation. Transitive. Okay, so let's take an example. Suppose we have a set A, it is a finite set with 3 elements. Okay, we have 1, 2 and 3. Okay, so what would be the smallest? We will be talking about smallest equivalence relation. What is the smallest equivalence relation? It would contain all the diagonal elements, that is 1, 1, 2, 2 and 3, 3. Okay, it is the smallest. So what would be the largest? It would contain all the combination. The largest equivalence relation would contain all the combination. Like it would contain 1, 1, 1, 2, 1, 3. Okay, and 2, 1, 2, 2, 2, 3. It would contain 2, 1, 2, 2, 2, 3. Okay, the same way it would contain 3, 1, 3, 2, 3, 3. So it would contain all the elements. Okay, for the smallest it is 1, 2, 3. The smallest, the size is n. Number of elements is n. If the set size is n, 1, 2, 3, we have n elements, so we have 3 elements. N elements. For the smallest, the equivalence relation size is n. For the largest, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. It is n square. N square. Okay. So we know our answer is C. Okay, because n square is only here. Okay. It is like the number of elements in the largest equivalent relation is n square. So answer is C. So now let us calculate the rank. What is the rank? Rank is number of equivalence classes. Number of equivalence classes. Okay, for smallest, let's see how we make the equivalence class. See, here 1 is related to only 1. Okay, so we would place 1 in a different class. Okay, 1 in a different class. Okay, and 2 is related to only 2. So we'll place 2 in a different class. 3 is related to only 3. So we'll place 3 in a different class. So we have 1, 2, 3. 3 equivalence classes, that is n classes. So it is equal to rank. Rank is n for smallest equivalence relation. Okay. For largest, let's see. 1 is related to 1. Okay. So we will place 1 in 1. 1 is related to 2. So 1 and 2 would be in same class. 1 is related to 3. So 1, 2 and 3 would be in same class. Okay, in the same way every other element is related to all other elements. Okay, so we have only one equivalence class. One class. So our rank would be 1 for largest equivalence classes. Largest equivalence relation. Okay, so it is all about this question. Our answer is C, that is n square and 1. Okay, it is the answer. Let's move to the next question. In this, consider the set of integer I. Okay, we have set of integer I where D denotes divides with the integer quotient. That is 4 divides 8, but 4 doesn't divide 7. Then what is D? Okay, see, let's see it like this. We have 4 divides 8. Okay, 4 divides 8. 4 also divides 12. 4 also divides 16. Okay, and so on. If we write 8 divides 16, okay, 8 divides 24. Here 4 also divides 24 divides 24. Let it we have it like this, A divides 24 like this. Okay, see, now we first check it for reflexivity. There is no reflexive relation, so it is not reflexive. Okay, and for antisymmetric, if there should be two elements like 4 4. Okay, it is not antisymmetric also, but it is transitive. We'll see how. 4 divides 8. Okay, 8 divides 16. Okay, and 4, that means 4 divides 16. It is transitivity. 4 divides 8, 8 divides 16, then 4 also divides 16. So answer would be B. That is not reflexive, not antisymmetric, and transitive. It is transitive. Okay, this was the second question. Let's move to the next. That is the third. Okay, in this, a bag contains 19 red balls. I'll write it like 19R, and 19 black balls. 2 balls are removed at a time repeatedly and discarded if they are of the same color. But if they are of different color, black ball is discarded. Okay, 2 balls are removed. That is, the combinations can be red red, red black, or black black. These are the combinations. Okay, if they are of the same color, they are discarded if they are of the same color. Okay, but if they are of the different color, black is discarded and red ball is written back to the bag. Okay, that is, in this bag we have total of 19 red and 19 black balls. Okay, suppose if we have red and black, okay, or black and black, in both cases black ball would be removed. Okay, red is only removed in pairs. That is, it would either remove 2 and next it would remove by 4, then next turn it would be removed by 6, and like so on up to 18. Okay, red would be always removed in pairs. Black, it can be removed in pair or it can be removed singly also. Okay, because when they are of different color, we are only removing black. We are putting red back into the bag only. Okay, so the final condition, there are the chances of three conditions in the end. Okay, it can be either red, red, or red. Okay, it is the first case, and the other case can be black or red. Okay, these can be the two cases in the last condition. If we remove 2, if there are 2 reds, if we take 2 balls, 2 reds, 1. It is the probability 1. Okay, if we remove 2 black, in this case he can have black first, then red would be in the bag. Okay, if we have black red first, then black would be in the bag and we would put the red back into the black. The black and red would be there. Okay, so for this case the probability of red is 1, ending up red with 1. For this case, suppose we are first removing black and red. Okay, so when we are removing black and red, black is removed but red is put again into the bag. Again we have black and red, so black is removed, red is again put back into the bag. So probability of being red is 1. So in all cases the probability of being the process terminating with 1 red ball in the bag is 1. So answer would be A. Okay, so this is the third question. Let's move on to the next question, that is the fourth. Okay, in the fourth question we have, if x is equal to 1 and x is equal to 2 are extreme points, so we can take it as maxima. Extreme points of fx is equal to alpha log x and beta x square plus x. Then the extreme points of, we have calculated the extreme points. So here we have x is equal to -1 and x is equal to 2. And we have fx is equal to, I'll write it once again, alpha log x, okay, plus beta x square plus x. Okay, how we can solve it? First we would differentiate it. We will solve f dash x. F dash x would be a of log x, it is 1 upon x. Okay, log x is equal to 1 upon x, plus for x square is equal to 2 beta x. Okay, for x it is plus 1. This is f dash x. For calculating extreme points, for extreme points, f dash x should be equated to 0. Okay, so we have to equate alpha upon x plus 2 beta x plus 1 is equal to 0. Okay, we have equated it. What we have now, x is equal to 1 and x is equal to 2. The first, sorry, minus 1. Where first we will put x is equal to minus 1 and again we will put x is equal to 2. When we put x is equal to minus 1, we would have alpha plus 2 beta is equal to 1. This is the equation. We would get this equation. When we put x is equal to minus 1, we would get this equation in the form of alpha and beta. When we put x is equal to 2, we would be having alpha plus 8 beta is equal to 2. This is for x is equal to 2. For after solving this equation 1 and equation 2, okay, we would get alpha is equal to 2 and beta is equal to minus 1 by 2. This is our answer. Alpha is equal to 2 and beta is equal to minus 1 by 2. That is B. B is our answer. Okay, is it clear? What we have done, we have just differentiated first time, equated it to 0 and we have put the value of x is equal to minus 1 and x equal to 2. We got two equations from there, and so after solving the equation we have the extreme points. Okay, let's move to the next question. That is, if fx is equal to log x and gx is equal to sin x, okay, we have fx is equal to log x and gx is equal to sin x, and if a is the range of f of gx and b is the range of g of fx, then we have to find the a intersection b. So let us have fx is equal to, we have log x. Okay, so range of log x, it varies from minus infinity to plus infinity. Okay, and for sin x it is minus 1 to plus 1. For gx is equal to sin x, it varies from minus 1 to plus 1. Okay, this is how it is. Now what we have? We have A. A is the range of, we have f of gx. So f of gx is log of sin x. Okay, so it would range from minus infinity to 0. Because here we have sin x, we can put log minus 1 here. Okay, and log 1 here. So it would range from minus infinity to 0. Okay, and we have here sin x, sin of log x. Sin of log x is, sin of log x, and its value would range from, any value of sin theta would range from minus 1 to 1. Okay, now let it be A, let it be B. Now we have to calculate A intersection B. So now what is common in this? 0 is there, in both of them 0 would be there, and minus 1 would be there. Okay, so it would be like 0, minus 1 up to minus infinity for this, and for this is minus 1, 0 and 1. So what is common here? This. So the answer is minus 1 and 0. So it should be B. Sorry, minus 1 and 0. Okay, it is same answer. B or A, it is same. Okay, both options are same. Answer is minus 1 and 0. Okay, so next question. Okay, it is the proposition. So we have here three terms, that is tautology, contradiction and contingency. What is tautology? When all are true. All true is tautology. What is contradiction? When all are false. Okay, what is contingency? It is neither tautology nor contradiction. That it is a mixture of true and false. Okay, now let's solve for our question. We have two terms, P and Q. So I'll write it as there would be 4 combination: true, true, false, false, true, false, and true, false. Okay, there are 4 combinations. Now first is P implies Q, and second is Q implies P. Okay, then we would be having intersection of both these. P implies Q, intersection Q implies P. Okay, first P implies Q. Here we would be having true. For both true it would be true, but for both false it would be true, and for right hand side true it would be true. So it is false. Okay, for this, but both true it would be true, but false it would be true. For P being true it would be true, and other it would be true over here, and it would be false. Okay, now and between these, true is true, it is false, and it is true. Okay, so here we have a mixture of true and false. So the answer is contingency. So it is C is the answer. Contingency is our answer. Okay, next move to the next question. Okay, if Tx denotes a trigonometric function, Px denotes that x is a periodic function, and Cx denotes that x is a continuous function. Okay, see, we have to write this statement in logically. Okay, so it is not the case. So remember, it is not the case. Okay, that some trigonometric functions are not periodic. So it is not periodic. So we'll be writing as not periodic. Okay, trigonometric functions are not periodic. Trigonometric functions are not periodic. Okay, we have it's right. We have written this, and it is not the case is there. So we would write there doesn't exist. Matlab it is false. This function is false. Okay, so our answer would be there doesn't exist. Some trigonometric functions are not periodic. Answer would be A. Okay, is it clear? Next. Okay, the number of elements in the power set of, let's see how we make the power set. Suppose we have two numbers 1 and 2 in a set. Okay, so the power set of this would be first 1 alone, 2 alone, and 1 and 2. Okay, this is a power set of elements with 2, that is 2 to the power 2, that is 4. Okay, but in this case we have duplicate values over here. So what we would write it in simplified manner, that is 1 2. We would be eliminating these duplicate values. So here also it would be 1 2, and we would be eliminating the duplicate values. Here also it would be 1 2. Okay, now all these are duplicate values. So our actual set is 1 and 2. Okay, this is one set. So we can write it as x also. It is x. Okay, if we have only one element, so our power set would contain null and x. So it is a power set. That is, for this our answer is null and 1 and 2. So it contains 1 and 2 elements. Okay, so answer should be D. Okay, this is our answer. Answer is D. Okay, now the next question is 9th. It is the function 0, 3 and 1 in the range of this defined by fx is equal to 2x cube minus 15x square. Okay, we have to tell that it is injective, surjective, or it is not injective or not surjective. So let's solve. For this we would be writing as, let fx is this. So I'll solve it over here only. We will be calculating f dash x. So for this f dash x should be 6x square minus 30x. 6x square minus 30x plus 36. This is our f dash x. So we can further simplify it like, it is like, we can further simplify it. I'll take 6 common. It would be x square minus 5x plus 6. Okay. Further simplifying, we would be having 6 x minus 3. Okay, and x minus 2. This is our f dash x. Okay, this is how we simplified it. Now see, for f dash x is greater than 0, you have to check for what? For x lies between 0 to 2. When x lies between 0 to 2, it is actually equal to f dash x is greater than 0. We have to put the values over here and you can check it. Okay, first put x is equal to 0, and if we put x is equal to 0, it is greater than 0. So we like this, you can check. Okay, now thus the function is increasing from thus the function is increasing from 0 to 2. The function is increasing from 0 to 2 and it is decreasing. When we put the value of 3, the value of function would decrease, and the function decrease from x is equal to 2 to x is equal to 3. Okay, so it is not monotonically increasing, not monotonically increasing or decreasing. Okay, if it is monotonically increasing or decreasing, then it would be 1 to 1. Okay, it is not monotonically increasing, so it is not 1 to 1. Not 1 to 1. So what is 1 to 1? 1 to 1 is injective. Okay, and so it is not injective. So not injective is here only. It is not injective. Here it is injective. It is not injective. This can be the option, or either this can be the option. Okay, now let's check. I put f of 0. F of 0. After putting f of 0, we will be having answer 1. F of 0. You have to put 0 over here. Okay, it is 0, 0 and 0. So answer would be 1. F of 0 is 1. And f of 2 would be 29. See, it is increasing. Okay, increasing. And f of 3, it would be f of 3 would be 28. 28. And it is decreasing. Okay, that is, it is surjective, that is, it is on to, that is, it is increasing and decreasing, but not 1, 1. So it is on to is surjective. So it is surjective but not injective. So our option would be B. Okay, it is surjective but not injective. Let's move to the next question. Okay, this is our last question. If we have two vectors A and B, and if they are perpendicular to each other, we have to find the value of A. Okay, if two vectors are perpendicular, that is we can write it as A vector A is perpendicular to vector B. If two vectors are perpendicular, then it is a property, you have to remember that, then their dot product is, and the dot product is 0. Okay, so now we can calculate the dot product of this, that is A dot B, it should be equal to 0. Okay, so how we would be calculating it is 2I plus lambda j plus k into I minus 2j plus 3k is equal to 0. So how the dot product is calculated? I is multiplied with I and j is multiplied with the coefficient of j, that is 2 into 1. It is 2. Okay, minus or plus, we will be writing plus only. Here we have lambda, here we will be having minus 2. So it is minus 2 lambda. Here we are having 1, here we are having 3, that is plus 3 is equal to 0. So we have minus 2 lambda is equal to 3 plus 5, minus 5, and lambda is equal to 5 by 2 is the answer. Okay, we have the option here, it is D. D is the answer. Okay, lambda is equal to 5 by 2. Okay, this was the first part of the questions of the question paper. And the next part we will be discussing about next 10 questions. So please stay tuned and please subscribe if you like the channel.